front desk, Julie, to the warehouse, to Chris, everybody will talk about microbes. Everyone will talk about nitrogen. Yeah, it fixes nitrogen, it fixes phosphate solubilization, it does this, that, so everyone knows about it. But yes, it fixes nitrogen fixation. The nitrogen fixation is a wonderful process that these microbes, you could classify them. There are symbiotic nitrogen fixation, there are free-living nitrogen fixers, there are endophytic microbes which are associated, and we also call root nodule forming rhizobia, and there are non-nodulating microbes which are also functioning as nitrogen fixers. Where is this nitrogen? This nitrogen is in the atmosphere. About 85% of nitrogen is in the atmosphere. You and me, I cannot absorb the nitrogen and convert it, but these microbes can harvest. So when we added this nitrogen fixers, selected it all, we found that they are fixing nitrogen, they are producing nodules in various legumes that we have tested, and with the different generation time among these microbes and different taxonomical classification. So it's not that one bacteria, oh, if it is drought, it dies. No, the other one is living. The other one helps the another bacteria don't die, okay, be alive. So there is a communication among the microbes. So the next one is the phosphate solubilization. The phosphate, many of your soil are rich in phosphate. When you analyze, you see it, but it's not in an available form. That's because most of the phosphate, when it is not utilized, it goes in a bound form with calcium or aluminum, and it's not available to the plant. There are microbes which can solubilize this unavailable phosphate and make it available. There are different groups of bacteria. It's not one group of bacteria. Even rhizobia, the primary function is nitrogen fixation, but the secondary one is phosphate solubilization and also mineral solubilization. Like that, it's a multifunctional one. The third one is the acid production and mineral solubilizers. These are all authenticated microbial procedures we applied to to classify and group the acid producers and the alkali producers, so that you get a gradient of pH in the soil, because all that we need is between 5.5 to 6.5. So this different communities, they maintain, they grade, they just build up a gradient of pH. Then very important one is the phytohormone production. That is very important. The rhizosphere microorganisms, they produce some phytohormones which accelerates, which proliferates. It activates the proliferation of the root in such a way, the branching. It's a high branching, and it makes the microbes associate with that one, and at the same time rich uptake, very high uptake of nutrients. And then of course the last point of it is very important, the soil and plant health builders for suppression of broad spectrum of pests and diseases. So that, in other words, I will say induction of host resistance and root health for broad spectrum of crops. This is something very important part of it. Like, we do not say that it's a pesticide, it's a biocide, it's an insecticide. No, never, never. We have several reasons, several scientific reports. We are just claiming that Sumagrow microbes, they help. They induce the systemic acquired resistance. I will talk more about that systemic acquired resistance, because tomorrow I have another talk where I'm going to just present you the principles of pest and disease management. So the long-term goal is this: stable, efficacious, and eco-friendly polymicrobial formulation, diverse groups of microbes with complementary functions, enhances growth, yield, and disease resistance of broad spectrum of plants, legumes, non-legumes, vegetables, cereals, ornamentals, and fodder crops, and all horticultural and floricultural crops, then reduce input of nitrogen, phosphorus, and potash fertilizer, which is very important, both inorganic and organic. Reduction, not elimination. We claim reduction. You reduce your input of inorganic or organic fertilizer when you use Sumagrow. then reduce and eliminate the need for chemical pesticides because it gives a systemic acquired resistance to the plants in such a way that the entire plant gives a resistance for the disease infection. And also the insects, they do not like when the plant leaves are high in bricks. Then it increases the nutrient value and increase soil organic matter, which is something very important, that the soil organic matter increase results in increased cation exchange capacity, which is again the plant nutrients or the ions. So which is very important for this invention. And here we start the story. I go with the, you see, I told you the sources. This is something very important. Root nodules of various legumes, forage legumes and grain legumes and then vegetable legumes. We took the root nodules and we isolated the bacteria. And I told you the rhizosphere, which is the gold, which is actually the precious zone of a plant. So the rhizosphere zone of cereals and vegetables and the legumes we collected from different soil, diverse soil, and also the soils from different areas, temperate, tropical, subtropical, we collected, and we did a total isolation of about 2,000 microbes, which later on, based on to their functionalities and functional characterization, we grouped them. We grouped them and we just narrowed it down to 200, and then we got everything identified, then we constructed and we designed this formulation. So the functional characterizations in Michigan State University, what I did is in Michigan State University, we did the entire functional characterization. This is impossible to do the entire thing in another place, because in university you have a multiple facilities from different faculties. So you can use the multiple facilities and day and night work for 3 years. We were successfully able to complete the very important functional characterization like nitrogen fixation. It's on the minus nitrogen free medium, and also we make the nitrogen fixation, we confirm by nodulation experiments. And then the phosphate solubilization using a tricalcium phosphate amended medium, then the phytohormones using tomato seedlings and even other legume seedlings, and their leaf areas were all taken into account, the root length and the shoot length and the seedling vigor were taken into account, and then the identification of the selected microbes, and then the acid and alkali production. The saprophytic competency is something very important, because the microbes which I am constructing in the lab, everything is in a controlled condition, everything controlled. The temperature is controlled, the contamination is controlled. So in such situation, this is produced. So it's all like when your baby at home, your baby you pamper. But when you send your baby to the school, it's a different atmosphere. So it should survive the external forces. There are many forces which are strong. So this is what the saprophytic competency. Your organism, when it enters into the soil, the best question everybody asks me, oh, are there not microbes in my soil? Your soil will have microbes, but you know, it is not the specific functionalities. And to see this effect of specific function, there is a very important quorum sensing. There should be a particular concentration. Together only it can do. It can function. So that is very important. And that was done. The saprophytic competency is very good. And then the shelf life, it's not less than 1 year when stored at cool temperature. And of course, we maintain the quality control by our frequent testing on the colony forming units. That's a CFU. Well, these are just the photographs I'm just showing. You can just see it, and that's for acid alkali production. You see this one. When you visit our lab, you will see this one. How interesting is this? Because this is a tricalcium as an amended medium. If a bacteria can utilize or solubilize, so it makes this hollow zone. It just utilizes, it dissolves, solubilizes the tricalcium phosphate. So we pick it up and then we grade it and then we choose them. We group them. So once you select the microbes, then you have to look for antagonistic effect. When Wayne says about the teamwork.